Docker networking fundamentals. Containers often need to communicate. Applications rarely run completely alone. Docker networking enables communication. Networking is essential for modern applications. Why containers need networking? Modern applications often include web servers, databases, cache servers, APIs, authentication services. All components must communicate. Understanding container isolation. Containers are isolated environments. Each container has its own processes. Each container has its own file system. Each container has its own network interface. Isolation improves security and stability. What is Docker networking? Docker networking enables container-to-container communication, container-to-host communication, container-to-internet communication. Docker automatically manages networks. Networking analogy. Office network. Computers connected. Communication possible. Docker containers work similarly when connected to the same network. Understanding IP addresses. Every network device requires an IP address, a network interface, communication rules. Docker assigns IP addresses automatically. How container communication works. Container A. Docker network. Container B. Containers communicate through shared networks. Viewing Docker networks. Command. Docker network ls. Displays. Bridge. Host. None. These are Docker's default networks. Docker default networks. Docker automatically creates bridge network, host network, none network. Each serves different purposes. Bridge network overview. Default Docker network. Used when no network is specified. Supports container communication. Provides network isolation. Most containers use bridge networking. Bridge network architecture. Container A. Bridge network. Container B. Communication enabled. Benefits of bridge networks. Easy setup. Network isolation. Container communication. Default configuration. Suitable for most workloads. Inspecting network details. Command. Docker network inspect bridge. Displays. Connected containers. IP addresses. Configuration information. Container communication example. Web application container. Bridge network. Database container. Applications communicate across the network. Why communication matters. Modern applications often use front-end service, back-end service, database service, cache service. Networking connects them together. Host network overview. Command. Docker run network host Jinx. Shares the host network stack. No network isolation. Container behaves like a native application. Host network architecture. Container. Host network stack. Physical network. No virtual network layer. Advantages of host networking. High performance. Reduced overhead. Simpler networking. Direct access to host network. Disadvantages of host networking. Reduced security. Less isolation. Port conflicts possible. Limited portability. None network overview. Command. Docker run network none Ubuntu. Networking disabled. No external communication. Fully isolated container. When to use none networks. Security testing. Isolated workloads. Specialized environments. Restricted applications. Understanding ports. Applications listen on ports. Examples. Port 80, HTTP. Port 443, HTTPS. Port 3306, MySQL. Port 5432, PostgreSQL. Containers use ports internally. The access problem. Application running inside container. Port 80. Not accessible externally. Port publishing is required. Publishing ports. Command. Docker run p8080:18 Jinx. Host port 8080. Container port 80. Port mapping explained. Browser. Localhost 8080. Docker port mapping. Container port 80. Jinx application. Why port publishing matters. Without publishing. Service inaccessible. Browser cannot connect. External systems cannot connect. Publishing exposes applications safely. Real-world example. Command. Docker run p3000:3000 node app. Access application. http://localhost 3000. Traffic is forwarded into the container. Viewing published ports. Command. Docker ps. Example output. 0.0.0.0:8080-80/TCP. Displays active port mappings. Container to Internet communication. Container. Docker network. Internet. Applications can access. APIs. Websites. Cloud services. Creating custom networks. Command. Docker network create network. Benefits. Better organization. Better isolation. Easier management. Connecting containers to networks. Command. Docker run network Jinx. Container joins the custom network. Benefits of custom networks. Improved security. Better isolation. Service organization. Cleaner architecture. Widely used in production. Network isolation. Network A. Container A. Network B. Container B. Containers on different networks are isolated. Security benefits of isolation. Reduced attack surface. Controlled communication. Service separation. Improved protection. Isolation is a key Docker feature. Real-world application architecture. Front-end container. Back-end container. Database container. All connected through Docker networking. Common networking commands. List networks. Docker network ls. Inspect network. Docker network inspect bridge. Create network. Docker network create network. Networking best practices. Use custom networks. Publish only required ports. Isolate sensitive services. Review network configurations. Follow security principles. Common beginner mistakes. Forgetting port publishing. Using incorrect ports. Assuming automatic communication. Ignoring network isolation. Interview question. Question. What does Docker run p8080:18 Jinx do? Answer. Maps port 8080 on the host to port 80 inside the container, allowing access through localhost 8080. Key takeaways and lesson summary. Docker networking enables communication. Bridge is the default network. Host networking shares host resources. None networking disables connectivity. Port publishing exposes applications. Custom networks improve security and organization.